the SOLIDNotes webinars. My name is Sam Saloom, and today we're going to discuss design intent and how to properly model your parts and assemblies using good design intent practices. Okay, so first off, we're going to discuss about what design intent actually is. Design intent is, your plan or your consideration of how the model should behave when it's changed. So when you make some type of either a change to a feature or an edit to a dimension or even removing a sketch relation, that change, that behavior that the model will act in is based off your design intent or what you planned it on to be. Bad design intent practices can be tremendously painful to you later on down the road. So most of the time, you create a model, there's a chance that probably about I want to say an 80% chance that you'll go and have to re-edit that model at some point in time. So you're constantly creating revisions, and because of that, we want to make sure that with good design intent practices, we can make those revisions as simple and as easy as possible without taking that much time. If you're wasting more time, if you're spending more time remodeling the part than when you initially modeled the part, that's showing some bad design intent practices. So that's what cruel design intent does. It allows for more rebuild errors, allows for more time on your part, creates more repetition, and in turn that's going to lead to more frustration and less productivity as a designer. So let's discuss before we go into explaining how design intent works, we're going to kind of discuss these little quotes from some famous people here, and they kind of go into detail on exactly where design intent can go, or cruel design intent can go wrong. And Albert Einstein once said, insanity is doing the same thing over and over again, expecting different results. Well, for me, insanity is doing the same thing over and over again. There's the quote by Ernest, and the happiness of most people is not ruined by great catastrophes or fatal errors, but by the repetition of slowly destructive little things. And I would consider changing a dimension and then your whole model creating numerous rebuild errors, something that's definitely a slowly destructive little thing. And you don't want to waste time doing that, so that's why it's important. That's why our founding father of Pennsylvania, Mr. William Penn, once said, time is what we want most, but we use worst. So anyway, now let's get back to the real topic at hand. So it's why do we want to maintain, or how do we maintain good design intent? And to do that, we have to understand what parts of our modeling techniques actually control or capture design intent. And you can control design intent using dimensions, sketch relations, equations, end conditions. And a good way to, and a good way to maintain best practices when it comes to design intent is to consider the possible ways that your model can change before you actually create the model, or as you're creating the model. And so let's go ahead and we're going to actually go ahead and create a part. And the part that we're going to create is we're actually going to go and create this crankshaft that I have here. It's a pretty intricate part with multiple extrusions, as you can see. And before we go into creating this model, let's think about what we later on down the road when we want to change what are our options to go with. And so I did that earlier. And so that's why we're going to our options for design intent. We want to make sure that the part is one connected solid body. We want to make sure that the offsets between the shafts and the transitions arcs are maintained. What that means is we want to make sure that that there is an offset between this arc and the shaft here. And again, we want to make sure this is one connected solid body. So if I make a change to a dimension, I'm just going to go in and change this dimension here. If I make a change to this dimension, it's still going to be one solid body. It's not going to, this extrusion is not going to go past the point here. It's not going to go past this feature. Or I'm not going to lose connections between those features as well. And then the other one is we want to make sure the shaft diameter is uniform throughout the part. And there's tricks that we could do this. There's actually multiple ways that we could do this, using equations, linking dimensions, or just a sneaky way of modeling. So let's go ahead and we're going to actually go ahead and create this crankshaft. We're going to start from new. Let's go to new, and we'll select our template. And I'm just going to create a sketch. And let's see, let's select. Now here's where you want to, now it might not come in too much big of a deal now, but later on down the road, when we go into end up creating our front, or end up adding this part into an assembly, it's important to take note in where we select our front, top, and right plane. What I find to be very tremendous in helping with assembly modeling is to model with planes instead of faces. And we'll discuss this in a little bit and talk about its benefits. So let's just be wary and just make notice for now of the plane selections that I chose. And it'll come into play later on as we move through the part. So I'm just going to select the front plane, and I'm going to create a sketch on that plane. And let's give this guy a dimension. Let's go with 120 millimeters. And then I'm also going to create another circle. And this time I'm just going to change that circle to a construction line. So I'll just click for construction here. Add a dimension. And we'll go about, let's go 90 millimeters. And I'm going to create another circle here for the bolt holes. Now, why am I taking these steps to perform this? Well, what I want to do is, what my design intent is for this part is I want to create multiple, I want to add multiple bolt holes, and I want to make sure that I do them and they're all the same size and they're all equally spaced between each other. And a good way to do that is to actually use the sketch pattern tool, and I'm going to use a circular sketch pattern. And for this circular sketch pattern, I just have to specify a point, and then I would specify the entities. And I want to make sure that this equal spacing option is selected. And that way I could create my, my circular sketch pattern. And let me just fully define this part. I'm just going to add a coincident relation there. Now again, let's talk about design intent. Let's talk about how the model is going to change when I make changes to it. So let's go ahead and just make some changes to it. So if I go ahead and change this dimension here, let's change it to 70. Now obviously all the bolt holes are going to shrink down to that 70 millimeters, so it meets that dimension. But say I didn't want to change that. Say I wanted to change that to 70, that's correct, but I didn't want, I wanted the offset between the outer circle and that bolt circle to be maintained. So what I could do instead is delete that dimension. And add a dimension here. And let's say I change that to 70. Again, that offset is still maintained. Where this, and also let's think about the number of holes I have. Let's change those. Let's see what happens when I do that. So if I go and change that to 8, they're still equally spaced, and they're still all going to be referencing the same dimension no matter what change I make. Let's go ahead. We only need 4 for our part here, and we're just going to keep that at 90. And we'll stick with the offset. So now I'm ready to extrude this part. And we'll give it a dimension of 20 millimeters. We're going to go with a blind end condition. That'll work. We don't really have any other surfaces to go up to or any vertexes as such to go up to. And so that's how design intent can be taken into play with on the sketch level. And that's how I was able to, and that would be a good design practice, is the model changed as if the way I wanted it to change when I made an alteration to it. So now I'm just going to select this face. I'm going to create another sketch. What I want to do next is I want to create this step shown here. Let's go ahead and do that. And let's open my sketch tab, and I'll go normal 2. And I'm just going to create, I'm just going to take a circle and give it a dimension of, let's say, 50 millimeters. And I chose to start at the origin. Always a good point to go with. And we'll extrude it out for 64 millimeters. And we create that first little step. Now, make note in how I create this feature here. What I'm going to do is I'm just going to create it right on here on this face. And I'm going to use the Offset Entities tool. And I'll just select the face. And it'll create a 10 millimeter offset of the model edges of the face that I selected. Which is good, which is kind of what we want in the end. So then I'm going to go and I'm just going to use the line tool, and I'll create that shape that I was looking for. If I hit the A key, I'll be able to auto transition into an arc. And then I'll just add sketch relations to help fully define my part. Oh, I don't need that. Let's go with 50. That works. And so now I have the part fully defined. I just need to use trim entities. I'll cut away at this part here. And then I'll just extrude it about 15 millimeters. And hit OK. Okay, so I've created that arc down here, and I used that 10 millimeter offset to create that arc with reference to this model edge. So now if I go ahead and make a change to this diameter, let's change it to 70, and let's rebuild it, you'll notice that the offset is maintained. And again, my design intent to maintain that offset is intact. Let's change it back to 50 and hit rebuild. And what else I'm going to do now is I'm going to make the next step shown here. So I will select this sketch, select this face to create a sketch on, and go normal 2. And let's select the circle tool, and we'll just create a circle going right off the center of this arc here. Now here's what I'm going to do here. I'm going to also add a 10 millimeter offset to this part here. And that'll actually allow me to maintain a uniform diameter for my shafts based on how the geometry was worked out, as long as the 10 millimeter offsets are equal. And let me just go ahead and show that too. So if I go ahead and change this part here, you'll notice that it'll change the shaft. It'll change the crankshaft in this location here as well, due to the offset and due to the quality of the offsets. So what I want to do, though, is I want to make sure that no matter what I do, that offset is always maintained at 10 throughout the whole part, just to keep it uniform, and that way later on when I make a change, I don't make any change, or I don't really mess up the model from doing that. So what I'm going to do is I'm going to create an equation. We'll go to Tools, Equations, and we'll create a global variable. We'll call it offset, or diameter offset. And we'll give it a dimension of, let's see, 10 millimeters. That's what we're using. Hit OK. And then I'll go ahead, and if I hit the equal sign and then select the global variable, go into the global variable tab and select my global variable, I can create that offset, or that offset to be equal throughout all these dimensions. And so build. Now say I go ahead back to Tools, Equations, and make a change to my equation or to my global variable, and then I'll hit OK. And then I'll hit Rebuild. You'll notice that the size is still uniform throughout the part. So let's go back to Tools, Equations, and let's change that back to 10. And so the next few steps are going to be very similar. For faces like this one, I would just use convert entities to have created it. I'm not going to really show you guys how to do that. I mean, SOLIDWORKS can help you out with showing you how to use convert entities. Same with this face. I just use convert entities from this one as well as this face from that one. And another thing I want to make a note of is I created this axis. And what I did is, in order to create this axis, I took the right plane and the top plane in order to create an axis. And I'm going to use this axis later on for adding mates to my part. So let's go ahead and let's switch back. Well, let's close out of this guy. Let's go ahead and let's switch back to the PowerPoint. And again, in our part design intent, the part is still one connected solid body. The offsets are maintained between the shaft and the arcs, and the shaft diameter is uniform throughout the part. And I also, let's go back to this part that we have here with the crankshaft. Another thing I also want to do is make sure that all these steps here, the distance between them is all equal. So what I could do is I could actually create a linked value in order to do that. I can link values. If I right-click on this dimension and select link values, and let's use I gave it a name before. I'm going to use that step length name, and then I'll hit OK. I mean, I created this name in the past, and all I had to do is just write in step length here, and then I hit OK. And now if I go to, if I right-click on this part, on this dimension, and click Link Values, and then what I'll do is that'll connect all these values together. And by doing this, I'm able to edit these values all at the same time. And you'll notice, say I went and took this number here and I changed it to 100, and you'll see that little link icon right next to the dimension telling me that this link is a linked variable, and I could turn that off by clicking on that icon. But I'm just going to leave it on. So if I change that to 100 and then hit rebuild, it's going to maintain that throughout all the other linked values. So that's another trick that you can use to maintain design intent. So what we actually did use to maintain our design intent was, the sketch plane selections, the sketch planes that we chose those faces, so we make sure that it's all one connected part. We used offset entities to maintain an offset. We used convert entities to maintain that the faces are still good. And then we also used link values to keep the parts together. There's a question here, and I'm going to answer it because I think it's a good, important question, and that's the difference between linking values versus setting a global variable. Okay, so really the only difference between the two is the linked values I can alter here, while the global variable that I had created, that can be changed here, but I'm not able to change the linked values there. Really, that's the only difference I noticed between the working of the two. And also in equations, I believe it'll be a lot easier. In equations, if you wanted to use that global variable later on in an equation, you'd have to set up the global variable. Linked values, again, they just share the same. Basically, it's only partly as much work as what the global variable can do, where you can use the global variable later on in equations. And again, to do that, all I would do is I would just right-click, select link values here on the dimension, and then I could type in a name, any name I want, and then I'll just hit OK, and it'll create that first linked value. And then I can go to use the drop-down and select all the ones from there. Okay. All right, so that's how we would use, that's how we would work with part modeling design intent. So now for assemblies, what we want to do is we want to try to mate with planes and axes instead of faces. And we'll also want to use equations to create planes that are referencing from standard planes. And the reason why we want to do this is because we want to avoid rebuild errors. Now let me ask you guys something. How often does this happen? Let's go into, how often do you go, and so for this part here, I have this part here that's a little bit too big for this shaft here. And I'm just going to open that part, and I actually have the feature to fix that created here. So how often do you go in and change a face to a part model, and then you go back to the assembly, and let's hit rebuild, and you get all these rebuild errors. Now why is that? Well, the reason why that is because a lot of the mates that you've created were referencing that, that face that you just changed, and now it's lost that reference. And a good way to avoid that is to mate with planes instead of mating with faces. And using these standard planes, which are your front, top, right planes that are in every model and can never be deleted from the model, is a better way of doing that because you'll always have those. So even if you don't have any features in your model, your mates will still be represented properly. And you won't have to worry about re-referencing them. So let's go and let's close out of this. And let's go ahead and, kind of running on time. So let's go ahead and I'll show you the completed assembly that I have. And let's turn it off. And we'll kind of discuss the mates that were added here. First, to start off, the initial mate that we had, what I did is I created, let me actually show that. Nope, I won't do that. Let's look for the crankshaft. So early on, I created an axis. And I'm just going to right-click here and allow this part to float. Early on, I created an axis within this crankshaft. And how I did that is I went to reference geometry shown here on the assembly tab, and I selected axis. And I took the the top axis and the right axis, and the center of those two created an axis shown here. And so what I did is I just mated those two together. And the reason why I did that is now this part, which is the only part of my assembly, can now rotate about that axis. And then I'm just going to go ahead and just make the two front planes together. And again, I'm only using standard planes and reference geometry created from those standard planes. So where if I were to go into this part, and let's say I took all these features here and I just deleted them, kept that axis though, but I made sure I did delete all these features. Obviously, I'll have rebuild errors in the part, but didn't actually do it. Let me make this easier. There we go. So I basically deleted most of the part, but you'll notice my mates are still intact. And that's what I kind of did throughout most of the part. Let's go and undo. Now you'll notice here that throughout the crankshaft, let's not rebuild. You'll notice here that throughout the crankshaft, the mates that we had were, we took, and let's only show, oh, no, we want to show the connecting rods. Let's suppress all those. Because all those other mates were just used by using copy with mates. So we have this part here, and notice the motion of the part. And what I did is I took, we have these mates created earlier, and then I used the connecting rod. Now the connecting rod, let me open that part and show you how that part works. That is actually a part, the same part with two different configurations. So there's a lower configuration and upper configuration. And where that benefits in is they share the same front, top, right reference plane, because the location of their cut is where those standard planes are. So that way, when I go and apply mates, those mates are applied using the front right planes. And then now let's suppress all these mates. So now this part's free to move, and we'll leave that guy out of the way. And now in order to mate this guy to the location here, what I'm going to do is I'm going to create a reference plane using, let's use the front. Actually, let's use the top plane. If I just hold the control key and then move up, I could set an offset. And I'm going to set that offset distance. Actually, I want to create this in the part. No, let's create this in the part. I'm sorry. Let's set that offset distance to be I want to say 64. Yeah, I think it was 64 that we had it at. And that's the center of this part here. I could change that. I probably will. But now remember how the way this is 65. That's fine, because what I'm going to do is I'm just going to use a global variable that'll link those two together. So we'll call that piston location. And the reason I'm doing this is so that I could later on use that plane to create an axis. So let's go ahead and set that equal to that global variable. Created that plane there. And now I could go ahead and create an axis from that plane. If we go to reference geometry axis, I'll select that plane and this right plane here. And then we could go back to our assembly. Let's hide that plane. And I could take, if I go to use the mate tool, I could take this axis that I created here, and oops, look, I could take this axis that I created here, and select the rotating axis that I created earlier, using the same way that I created axis 1. And I could create that mate as shown there. And again, that axis is referencing the original standard mates, the original standard planes. So if I make any changes to this guy here, as long as I'm not deleting that axis, if I make any changes to the actual geometry, I don't get any mate errors. Let's bring that back. And then we just used, what I could have done is I could have created planes throughout each one of these steps and then used equations to reference those again. But I just used, for the interest of time, I just used a width mate. And then we took the pins and then we just applied mates to that for the cylinder, just using those standard mates, and that was based on how the model was created. Why not? And that was based on how the model was created. And the reason why I'm creating these axes off the standard planes and not the temporary axes is because those temporary axes are linked to the actual geometry of the part. So if I make any changes to that geometry of the part, so if I link it to so if I made it using the temporary axis for this guy, and say I deleted that circle, that would be lost. And so that's why I decided to use that. But again, we have these, again, I'm using the planes to create some of these mates here. And I'll mate the right plane, which is that side plane, to the front of the cylinder there. And then I'll just want to locate it in the same location as the connecting rod. And there we go. We are able to have our motion. Due to those mates that we created. Now, if we take a look at this cylinder that I created, you know, I could have created this differently, but based on how I created this part, you know, I had consideration in where I wanted that origin to be placed and where I wanted the planes to go through. I made sure that the planes all went through the origin point of this bore here. And the reason for that is so that I could later on mate it with the pin. So that kind of discusses assembly part modeling. So I want to thank everyone, and actually just to recap a little bit. You know, in the beginning we discussed part design intent modeling. We discussed the different ways to use that using equations. We also discussed assembly design intent modeling, and we discussed using mating with planes and axes instead of faces. So I want to thank everyone for coming. Again, my name is Sam Saloon. This is Chapter 12 of SOLIDNotes webinars. If you have any comments or questions or any suggestions for future SOLIDNotes webinars, you can send them to my email, and if you need any assistance with support, contact us at support-designpoint.com. I'm going to leave it up to questions right now. I know we kind of went a little bit over time, but that's okay. Does anybody have any questions that they have at all?